Artificial intelligence is making rapid strides. There's talk of a new evolution that could fundamentally change life on our planet. Artificial intelligence has the potential to revolutionize every aspect of daily life: work, mobility, medicine, the economy, and communication. But will AI really make medicine better and doctors superfluous? When will self-driving cars hit our roads? Will intelligent robots usurp our jobs? And are we heading for a dystopia with no privacy and total surveillance? What exactly is artificial intelligence, and how much can it really do? What will change, and what will remain pure fantasy? To answer these questions, we embarked on an exciting journey to meet the scientists working on our future in the US, Britain, Germany, and China. Our first stop, Silicon Valley in California. Apple, Google, and Facebook all have their headquarters here. It's the epicenter of the digital revolution. The tech industry has changed the face of the San Francisco Bay Area. New startup companies launch every day. Rents have exploded, and artificial intelligence is the buzzword. A new type of supermarket recently opened its doors here. Amazon Go. All you need here is an app.
Since you have an Amazon account already, please
hold your mobile phone to the scanner and you're in. As Leonardo shows me Amazon's new menus and explains that the language assistant Alexa can help with the preparation at home, I'm under constant surveillance. Which shelf do I stop at? Which products am I interested in? On the ceiling, sensors and cameras. Intelligent image recognition captures my every move. What do I take off the shelf? What do I put back? And what do I take with me? This branch is still in its test phase, but Amazon plans to open 50 such grocery stores this year alone. The end of the sales assistant. Just walk out. No more standing in line. No cashiers. I feel a bit like a shoplifter as I leave. Comfort at the cost of privacy. My receipt. One block away, a robot cafe. Another test lab for the future. Order by app and touchscreen. The increasingly ubiquitous tools of trade. My first ever cup of coffee served by a robot. So this is the taste of the future. AI will change our shopping experience, but what will happen to employees? Stanford University is at the forefront of global AI research with an annual budget of $6.5 billion. I want to know, how will artificial intelligence change medicine? Researchers here have developed an artificial intelligence algorithm that can screen X-rays for certain diseases. Computer scientist Pranav Rajpurkar shows me how easy it is to use. Take a picture of an X-ray with your mobile phone, upload the image, and a few seconds later, you get the diagnosis.
It's a mass, and it's saying this thing over here is a possibly cancerous lesion. Ooh. And I can see that right over here.
Okay, so it gives you, if I may have a look at it, now probabilities for pneumonia, a nodule, edema, effusion, and that goes bang.
Yeah,
Now, how does this work? I mean, how did you get to the point?
We started with a large data set of chest x-rays, which were released by the NIH, and these contained x-rays and then also labels of different pathologies and whether they existed in those x-rays. So it might say, okay, here's an image, and on this image I have pathology 1, 2, and 3. And we had 100,000 of these images. So we trained a model that can take as an input an X-ray and then output the probability of several different pathologies on this X-ray.
Artificial intelligence is modeled on the human brain, a gigantic network of almost 100 billion interconnected neurons. Put in very simple terms, this is how a brain cell works. Incoming impulses are passed in a domino effect from one neuron to the next. The resulting circuit connects the neurons, and it is this circuit that artificial intelligence tries to simulate as a digital neural network. Like our brains, the network can learn how to identify tuberculosis, for instance. First, the network needs to be trained or taught. X-rays of tuberculosis patients are fed to the system. Initially, it struggles to correctly identify the condition. But every time an X-ray is fed in, the network's structure is adapted and its diagnostic ability improves. It takes thousands and thousands of clinical datasets to train the machine. Only after the network is optimized in this way can it correctly identify an unknown X-ray. But how accurate is artificial intelligence compared to a doctor's expertise?
We have actually done this test twice at this point. Once with a set of studies from the NIH data set that we had a group of radiologists label, and then we compared the accuracy of the model to the radiologists, and we found that they were very similar in terms of accuracy on most pathologies. On one of them, the model was outperforming the radiologists, and on 3 of them, the radiologists were outperforming the model. And then we repeated the experiment, this time using a data set from Stanford, which we recently released, which is 200,000 chest x-rays. And then we had a similar setup where we had 3 subspecialty radiologists. These are very uncommon, very trained radiologists to decide what the ground truth for a particular set of images was. And then we compared general radiologists to the algorithm at the task and found that they had similar levels of performance. So these are all Stanford radiologists, so they're trained.
They should be good.
Yeah.
Reading X-rays accurately is a complicated process, but artificial intelligence is making fast progress. When it comes to identifying or recognizing simple images, computers have surpassed human accuracy.
Now, if I look at your picture, it's always probabilities. So there are cases where the machine is not really sure. What would be sort of a clear decision to say, okay, this is, I don't know, pneumonia or something else?
Yeah, I think it's good to talk in terms of probabilities, because probabilities also give a sense of the algorithm, the model's uncertainty on that particular problem. I think one difficulty with probabilities is that it does make it hard for humans to interpret. Like, what does a probability of 88% versus 92% mean in terms of the decision I should make in the clinic? And so I think in that sense, one of the things that we could experiment with doing in the future is, rather than showing probabilities that are so fine-grained, maybe we can show things like unlikely, or this pathology is likely, or this pathology is possible.
In healthcare, artificial intelligence is powering a revolution. Scientists are using artificial intelligence algorithms to sift through seemingly banal data, such as the up and down motion of the steps we take every day. They're looking for conspicuous patterns that could serve as early warning signs of disease. Scientists in the English city of Birmingham are working on a revolutionary diagnostic method